studying total solar eclipses have revealed some of the most fundamental discoveries in science today. During these celestial events, scientists discovered the sun's structure, the first proof of Einstein's theory of general relativity, and the element helium, 30 years before it was found on Earth. They also discovered huge solar explosions called coronal mass ejections, eruptions on the sun that continue to be an important component of NASA's research. Coronal mass ejections, or CMEs, are giant eruptions made up of hot gas and plasma. From the sun's surface, they propel immense clouds of solar material into space, speeding at up to 1 million miles per hour and carrying enough energy to power the world for 10,000 years. Sometimes they're directed towards Earth when they can affect our planet's space environment, causing space weather. Scientists track and study CMEs because they can trigger global changes in Earth's magnetic field. When intense, these can create magnetic storms that can cause aurora, but can also affect satellite electronics and power grids on the ground. Scientists discovered these eruptions in the 1970s during the beginning of the modern satellite era, a time when satellites in space were able to capture thousands of images of solar activity that had never been seen before. But in hindsight, these might not have been the first time scientists had noticed these solar features. Soon after they discovered CMEs, scientists came across reports of a total solar eclipse in 1860 that looked very similar to their satellite images. On July 18, 1860, the shadow of the moon traveled over North America, Spain, and North Africa before departing Earth. Much of the path of totality traveled over populated land, resulting in a wealth of observations. Back then, astronomical photography was still new, so many scientists recorded their observations by hand. The drawings show the large white fingers of the corona, and also a distinctive arc-like feature. With multiple images drawn from different locations across Europe, it appears to evolve over time, but not all the images showed this. About 2/3 of people saw the tulip head-like shape, but 1/3 didn't see anything at all, including renowned scientist Angelo Secchi. It wasn't until over 100 years later, with regular satellite imagery, that scientists reopened the debate about what was seen in the 1860 eclipse. The strong resemblance shows that this eclipse may be the first record of a CME. While satellites in the space age exploded the field of CME research, total solar eclipses seen from the ground still provide unique views of the sun's atmosphere that help our understanding of what causes these explosions. Current instruments in space studying the corona need to block the sun's bright body with an occulting disk. The disk covers up the sun and a portion of the lower corona, an important region that scientists believe is responsible for accelerating CMEs and forming solar wind. So when eclipses happen to fall on land, scientists take advantage of these rare events. With each new total eclipse, there's the chance for new information and new research, and the chance to reveal something as astronomical as the first CME.